Hello students, in today's lecture, we are going to learn about decimal fractions. Now, first of all, let us learn what are decimal fractions. Fractions we have done, right? Fractions means part of whole. Now, what are decimal fractions? And for that, first of all, we need to go back to the place values, okay? So when we write number, suppose say for example, 2, 3, 5. So this is our units place, this is tens place, this is hundreds place, right? That is hundreds place, okay? Now, this is ones place, tens place, hundreds place. If you go towards this direction, the every next place is 10 times the other. 1 into 10 is 10, 10 into 10 is 100, then next place becomes 1000 and so on. And they are more than one. All these are more than one. As in the if you go in this direction, this is thousands place, then hundreds place divided by 10, then tens place divided by 10, then ones place divided by 10. What happens if I go again here on this side? Now this side, this is 1 when divided by 10, it becomes a fraction, 1 upon 10. Yes, so next place is 1 upon 10. Next place is 1 upon 100. Next is 1 upon 1000. Every time divide by 100. Every time divide by 10. So 1 upon 10 divided by 10 is 1 upon 100. Divided by 10 is 1 upon 1000. So these all numbers are fractions. They are fractions means smaller than 1. While this part is a whole number. Whole numbers or integers we say actually. Whole numbers or we say integers. So suppose if we want to write all numbers together, they should be bifurcated by some symbol. And that symbol is nothing but this decimal point. This point is called decimal point. This is decimal point. This divides the whole number into fraction and integer. This part is left-hand side part is the whole numbers or integer numbers, and this side they are fractions. So see the place values here. If this side, from here if you go towards left, into 10, into 10, into 10, into 10, it is like that. Okay, so this part is fraction. And now, for example, look here. Suppose I want to write 5 upon 10. So 1, 0. This is 5 upon 10. Here I will write 5, then this becomes 5 upon 10. Okay. See, for example, let us do once again now. Now I will take decimal number. Number with decimal point is a decimal fraction. Here I will write point and 5. So what is the place value of this 5 and this 5? Here the place value of this 5 is 5, while place value of this 5 is 5 upon 10, because it is one digit after the decimal point. One digit after the decimal point, because this place is 1 upon 10 or a tenth. It is called tenth place. So the place value is 5 upon 10. Suppose I write one more digit over here, then value of this 2 will be 2 upon 100. It is like this. So suppose I want to write, this number in a decimal fraction. So how to write this in decimal? Write 3 over here. Then because there are 2 zeros, skip 2 digits. That is, one is 3, other is 0, and then put decimal point. So this becomes 3 upon 100. 0 point. Here nothing is there. So here I will write 0. 0.03 is 3 upon 100. So like this, there are decimal fractions. Now what we are going to learn is how to do addition, subtraction, multiplication, division using this decimal fraction. Like fractions, they are also sometimes difficult, or maybe children make more mistake here. Students make more mistakes in these fractions and decimal fraction. If your single decimal point, place of decimal point is wrong, single digit is wrong, even then the answer is wrong. And so while doing these sums, Do carefully and practice more. So let us start. Yes, look at this. This is our first question. Look at this question. Now here, while adding decimal fractions, first of all, we have to see how many digits are there after the decimal point. So for addition, what we need is there should be like decimal fractions. Okay, so what are like decimal fractions? Decimal fractions, that is 0.45, 0.72, 0.09. Everywhere there are 2 digits after the decimal, and therefore they are called like decimal fractions. And then it becomes very easy to add them together. You have to write them one below the other in such a way that decimal point also should come one below the other. So here I can do like this: 0.45 plus 0.72 plus 0.09. And suppose if the another fraction is given like this, 0.1, then this is not like fraction. Then how to make them like? Just add 1 0 over here. So now there are 2 digits. If I write 0.1, this is nothing but 1 upon 10. And if I write 0.10, this is nothing but 10 upon 100. And if you simplify, it becomes 1 by 10. And therefore value remains same. And now I have converted this into like decimal. And now I can add them together like this. Simply add them together. Carry over comes, take over here. It is simple addition. Only the thing is you should arrange the numbers in such a way that decimal point come one below the other and number of digits after the decimal point should be same. In our first sum, they are already given like fractions, so simply add them together. So let us add 4.099 plus 1.001. Just add them. 9 plus 1, 10. Carry over 1. Again 9 plus 1, 10. Carry over 1. That is 1. Now put the decimal point here and 4 plus 1, 5. So this is answer 5.100. But this is equal to 5.10. This is also equal to 5.1. So all the 3 answers are right. Now what is given in our option? This is given D. So this is the correct option. This sum was simple. It was just of addition sum. So let us move to next question. Yes. Now this is very important sum. Look here. 5 upon 7. In fraction we have done, right? Now here we have to convert it into decimal form. Every number can be, every fraction can be written in the form of decimal fraction form, right? How it is to be done? We have to divide numerator by denominator. First, I'll give you few simple sums here. Say for example, 7. For example, say 7 upon, instead of 5 upon 7, I will take 7 upon 5. 7 upon 5, right? So just let us divide this. 7 divided by 5. So 5 ones are 5. 2 is remaining, right? Now what to do? Put decimal point and add 0. Here, now I am bringing down this 0, which is after the decimal point. So here also I will put decimal point. And now it is simple. 5 4s are 20. And the remainder is 0. So the answer is 1.4. Very simple, right? Now we'll take other examples, say 12 upon 25. Now this time, this is proper fraction, okay? Let us divide. 12 divided by 25. It is not divisible. So first of all, let us write 0. Now I am putting decimal point and adding 0 over here. Here also I have to write decimal point. And now apply Now let us do division as usual. Consider this number as a 120. So 25 fours are 100. 0. Again, one more 0. See, after decimal point, you can go on adding zeros. The value will never change. And therefore, one more 0 I have added. And now it is 25 8s are 200, 0. And therefore, this 12 upon 25 is nothing but 0.48. Now here in these cases, we are getting remainder 0. But there are certain numbers in which certain fractions in which this division process never ends. Let us see such example. 12 upon, here it is 7, now we'll take 11. 12 upon 11. So let us divide 12 by 11. First of all, it is 11 ones are 11. It is simple. Remainder is 1. Then put decimal point and add 0. Bring down this 0. Here also put decimal point. Again, 10 is not divisible by 11. So I will write 0 over here. One more 0. And now 11 nines are 99. Again, what happens? 1 will remain. Bring down next 0. One more 0. Again 0. Bring down one more 0. Again 9. 99. Again I am getting 1. See, from here I am getting remainder 1, remainder 1, remainder 1. And what I am getting? 09, 09, 09. So these type of fractions, decimal fractions, are called recurring decimal fractions. Recurring decimal fractions. Here what happens? If you do division, it will never end. Every time after certain period, you will get same remainder. Like here, I have got remainder 1. Here also I got remainder 1. Here also I got remainder 1. Same remainder I am getting and same quotient I am getting here. 09, 09, 09. Group of these two digits reoccurs. That is why these fractions are called recurring decimal fractions. And therefore, such fractions are written as 12 upon 11 is equal to 0. Sorry. It is not 0. It is 1 is there. This is 1.09 bar. 1.090909. If you go on doing, you will get same two digits again and again. And then it will be a recurring 1.09. Okay. So whenever the denominators are like this, some prime numbers like this, we get denominators, we get recurring decimal fractions. Okay. So let us see the given sum now. This was just example what are recurring decimal fractions and what is this given in answers. Some bars are given on these numbers. So what are they? So let us see now. Let us divide this 5 by 7. So actual division we will do. It is a lengthy process. 5 divided by 7. As we know, 5 is not divisible. Let us put 0 over here. Then put decimal point, 0. Again, decimal point. And now 7. 7 sevens are 49. Subtract. We will get 1. Bring down one more, add one more 0 and bring it down. Now 7 ones are 7. 3. One more 0, add here. 7 fours are 28. Every time do subtraction. Same division process. 20. Again now 7 twos are 14. Because 7 threes are 21. This is smaller. Therefore 7 twos are 14. What is remaining? 6. Now I will take this 6 over here. 6. Okay. Let us add one more 0 and bring it down. So it will be 60. right? Now let us divide 60 by 7. So 7 8s are, I will write over here, 7 8s are 56. What will remain? 4. Again, one more 0, bring it here. So it will be 40. 7 5s are 35. Right? And now 5. We started with 5 and again we got 5. So if you do division, you will get same digits again, a group of all these digits again. So whenever you divide by 7, if the numerator is not divisible by 7, you are going to get these group of these digits again and again, again and again. And therefore, I will write that 5 upon 7 is nothing but 0.714285 and bar, because this is an endless division. Again we got 5. We started with 5 and again we got 5. So again we will get same group over there. And it is denoted by this symbol bar. So this is recurring type. And now let us say 714285. So here the answer is B. And one thing more regarding this 7. Here you can try at home afterwards. Find out 1 upon 7, 2 upon 7, 3 upon 7, 4 upon 7. We have done 5 upon 7 and one more 6 upon 7. Same digits you will get, but they are in a different order. For example, suppose if I do 2 upon 7. Where is my 2? I'm getting 2 here, right? So 2 upon 7 means divide this. So here it is 7 2s are 14. So from here it will start. And the answer of this will be 285714. 0.285714. Digits will be same, but only the order will be different. Answer of this. So you try these 4 at home. Okay, practice this sum. So let us do now next sum. Yes. Look here. Now what is given to us? 2002 into 101 equal to 202202. Okay, and now the same numbers are given in decimal fraction form, right? Now in multiplication, remember this simple examples. Let us take first. Say 1.5 into 1.2. Suppose if the question is like this, just do the multiplication directly. We can do by 12. 12 5s are 60. Carry over 6. 12 ones are 12 plus 6, 18. This is the actual product. First of all, ignore the decimal point and multiply. So this will be the product. Now you have to count number of digits after the decimal point. How many are there? 1 and 2. So from this right hand side, you have to count 1 and 2, skip those and put the decimal point. So here what is the answer? 1.8 or a 1.80 will do. Okay. So same rule we have to apply here, right? See, now the numbers are same. Here, if you ignore the decimal points, it is 2002 and 101, same. So here the product also will be same. Only the question is of decimal point. 0.101, right? So first write all these numbers as it is 202202, because if we ignore this decimal point, the product will be same. But now if the decimal points are there, count number of digits after the decimal point. 1, 2, 3, 4, 5. And then from right hand side, 1, 2, 3, 4, 5. And put the decimal point, right? And so which is the answer? Yes, 2.02202. 2.02202. C is the answer. Understood? Very simple it is. Do multiplication as usual, then afterwards count the number of digits in the given sum, and from right hand side skip those digits and then put the decimal, right? Like here 5 digits are there in all, so we skipped 5 digits and put the decimal. Okay, so this is the way how we do multiplication in decimal fractions. Let us move to next question. Yes, now this is division. Okay, let us see how division is done. 2, 4, 9, 4 divided by 1.45. See here, there is a slight correction. Instead of this, it is 1720. The answer is 1720. So here the product is 1720. Okay, and then what we have to find out is, see, the numbers are same, only the place of decimal point is changed. So answer also somewhere here only, the place of decimal point is slightly different, right? So how to do? First of all, in the denominator, remove the decimal point. How the decimal point can be removed? See, for example, when you multiply any decimal fraction, say 2.75, if you multiply by 10, the decimal point will get shifted one place to the right side. Okay, and answer will be 27.5. If you multiply by 100, this decimal point will get shifted two places on the right side. So while doing multiplication, shift the decimal points towards right according to number of zeros. Here 2 zeros, so shift two places here and answer will be 275. Right? If you multiply by 1000, 2.75, 1000. So 1, 2, 3. Put 0 over here. Now your decimal point will be here. And the answer will be 2750. It is like this. It is so simple. Just move the decimal point. While doing multiplication, shift the decimal points to the right depending upon the number of zeros. And in case of division, shift the decimal points toward left. Same rule, right? So here what we will do, we want to remove this decimal point. So multiply this by 100. Okay, and then what will happen? Let us see what will happen. It will be 249,400 upon 145. Right? Now decimal point is removed here. I have multiplied by 100, two places on the right side. And this is equal to 1720. Okay. Now here what we will do? First of all, make the like fractions. Now we are going to use the same thing over here. One more thing. 2494 upon 145 into, say, 100. Let us do 100 like this. Okay. So this is nothing but 1720. Or keep it like this. Let us see how we can make a use of this over here. First of all, let us add one more 0 over here. So now they are like fractions. Multiply both by 100 because two digits are there, and therefore I will get 2494 upon 1450. Right? Now look here. What is this? One more thing here. 2494 upon 145 into 10. It is like this. So first let us find out the value of this from here. Look here. We want value of this. This value, if we substitute there, we will get answer. And for that, we need to take 100 this side. Means divide both the sides by 100. Okay. Cancel these zeros. And here what will happen? Now let us put the decimal point. Two zeros. So 1 and 2. Skip 2 and answer is 17.2. 20. You can say 17.20. And now for this part, same part, we will write 17.20 and this 10 is there in the denominator. Now we are dividing by 10. Dividing by 10 means shift the decimal points towards left. How many places? Because here there is 1 0, so only one place. And therefore this decimal point will go here. And the answer will be 1.720. This is nothing but 1.72. And here the answer is D. This is the answer. Remember well, while doing division of this type of decimal fractions, always do carefully. See the number of digits after the decimal point. The answer is there. Only you have to place the decimal point correctly. That's all, right? Okay, so let us do next now. Yes, here again, same thing. Look here. Yeah. The given sum is 347. See, you will think that, oh wow, what a complicated number, how we can do division, this type of division. But see, I will show you the easy method. 347.4471 upon 0.0089. So in such sums, denominator is very complicated number, right? Decimal fraction. So let us first remove the decimal fraction. So it becomes easy. Now, how many are there digits? How many digits are there? 1, 2, 3, 4. So if I multiply this by 1, 2, 3, 4, 4 digits, 4 zeros. So decimal point will get shifted up to here and then we will have 89. Decimal point will go. But same thing is to be done here. And then what will happen? Decimal point will go 3, 4, 7. Here also 4 digits. 1, 2, 3, 4. Here also 1, 2, 3, 4. And therefore 3, 4, 7, 4, 4, 7, 1 upon 89. And the answer, this answer is given to us 39039. Correct? So this number is, answer quotient is this. Now what do we have? In our question, what is given? 347,447 upon 8900. We have only 89. Here it is 8900. So what I will do? 3474471 upon 89 into 1 upon 100. I am taking that 100 separately. Okay, because this result we have, this is 39039, and this 100 we have to take in the denominator. So now we are dividing this number by 100, 2 zeros. So shift decimal point on which side? While doing division, we shift decimal point in the left side. And how many places? 2 places. So skip 2 places. Decimal point will be 390.39. It will be 1 and 2. When decimal point is not given, the meaning is it is in the last. When I write number 752, no decimal point is given. The meaning is it is 752.0. Okay, so here the point is somewhere here, and that is to be shifted 2 places this side. So answer is 390.39, right? So this is the answer. Our option is C. Is it okay? So this is how division is done. We have done this. This is the last one now, I think. Let us see. I don't know whether there is any, but let us see. This is again division. Okay, so let us first simplify first part. Let us write the sum. 0.117117 divided by 0.13 plus 0.133133 divided by 0.19. See, if there is a decimal point in the numerator, it is okay. But denominator should be without decimal point. So try to remove decimal point in the denominator. So what I will do, I will multiply this by 100. And this also by 100. So naturally here also I have to multiply. Equivalent fractions we have done. Okay. So what will happen? Denominator will be 13. And here it will be 2 places this side. So it is 11.7117 plus here also it is 13.3133 upon 19. Right? And now this number, if you know the table, 13's table, it is 13 9s are 117. Right? And here it is 7s are. Okay, let us find the answer here now. This is, let us divide this. Again, division is slightly difficult. We will do here. One we will do, so we will get an idea about the second one. 11.7 11.7117, right? Divided by 30. 11 is not divisible. So let us write 0. Then now we are using digit. We are using 117. So digit which is after the decimal point. So put decimal point here. And now 9s are 117, 0. Bring down 1, which is not divisible by 13. So put 0. Bring down next one. That is also not divisible. Put 0. And then 7, 9. So what's the answer here? 0.9009. And similarly here, now same thing will happen here. It will be 0.7007. And now let us add them together. Here we'll do addition. 0. Like terms, 4 digits after the decimal point in both the numbers. So no need to change anything. Just add them. So here it is 16, 0, 16, 1.6016. Look at the answers now, options. Very simple it is, only the thing is, here you have to do actual division. Actual division, do actual division so that the number of zeros in between should be correct. Otherwise, sometimes what happens, you will write 99. For example, this is just I'm showing you how you make mistake. 117 divided by 13. Many times what happens? Yes, 13 ones are, 9s are and 9s are. But no, it is not. First you do 9s are, that is okay. But afterwards you bring down 1, which is not divisible. So 1, 0 here. Then again when you bring down 1, that also is not divisible. So again 0. So there are 2 zeros. These 2 zeros. While doing this type of division, be careful about these zeros. Don't write 99. Okay? And therefore, these are the two answers. Then add them. Our final answer is 1.6016. Yes, this is the answer. So this was regarding again division. Many times decimal fractions division is sometimes difficult. So you have to be very careful. Put the decimal point at correct place so that your answer will be correct. Okay. So let us, I think this was the last question. Okay. So many sums, if you see the book, if you refer the book, you will find these type of sums. And one more book is their past papers book. Yeah, we have published one book which has so many past papers. So these some questions are from past papers only. So you will have an idea that how the questions are asked in the paper, right? So go through that book, try to solve them and keep practicing. That's all for this lecture. Okay.